So Greg, tell us how you managed to get to where you are now in your career.
In a very circuitous way. I became interested in all things health and physical performance when I was 12. I hurt my back playing rugby, and that coincided with a time when I became interested in girls too. So I spent a lot of time at school in my free time finding out about things like nutrition and exercise. Ended up at Loughborough University, did an undergrad and a master's in exercise science, focusing on exercise physiology. Did lots of coaching at that time, worked in particular with strength and power athletes and sprinters primarily. Also worked as a sports massage therapist and personal trainer. And I realized then that biological rhythms and sleep are key to all aspects of how we feel and function too. So I started looking for PhDs on that subject and wound up at the University of Leeds, did a PhD focusing on the intersection between sleep, nutrition and metabolic health. And while I was there, I met a guy named Dan Pardy, who is the CEO and founder of Human OS. And I became content director, creating things like blogs and podcasts and online courses, teaching people about how lifestyle affects health and performance. And I also started doing a fair bit of public speaking around that time. And then around when I wrapped that up, I started my own consultancy side hustle. So started working one-on-one with people, also with small groups of individuals. And then around 1 year ago, I co-founded a company named Resilient Nutrition with my good friend Ali. And Resilient Nutrition is a UK-based nutrition company that creates products that hopefully help people feel and perform better. And we also, of course, try to teach people about not only nutrition, but how other aspects of lifestyle affect health. Because I think a lot of people are confused about those things, given that misinformation tends to propagate faster through social networks than accurate information does. So with all of that said, the commonality behind the work that I've done to date is using lifestyle to prevent the transition to chronic disease and to help people perform at their peak so that they can get more out of life.
Sounds awesome. If we just circle back to your PhD that delved into circadian rhythms and sleep, what were some of the key findings you got from there? And also, what initially triggered your interest in diving into sleep as a specific? You said you became interested in circadian rhythms, but was there any personal experiences there, or did you just stumble upon something that was really fascinating?
Never quite put my finger on exactly what triggered that interest. I think it's a combination of my personal sleep, which is quite unusual. I'm a very early chronotype. Chronotype is a construct that describes whether somebody's more of a night owl or a morning lark. And since I was born, I have been probably in the first centile of larkness. So when I was young, while most kids will try to convince their parents to let them stay up later, I was always saying, "All right, night, Mr. and Mrs. P, I'm off to bed." And even at my latest, when I was about 19 or so, I don't think I ever stayed up much later than 11 p.m. unless I was out with friends or whatever. So it's probably a combination of that, but then also stumbling on research related to sleep and people discussing that subject and realizing how fascinating it is. And those exposures included listening to people like Dan Pardy, who I mentioned earlier, discuss sleep on podcasts, but also I began reading some of the scientific literature, in part to prepare for writing articles for certain websites. For example, I remember writing an article for Elite FDS when I was probably 21 or so about sleep and athletic performance. And that spawned that interest. And then with respect to my PhD and what we found out, nothing groundbreaking would be the answer. But I did some epidemiology work looking at the relationships between how people sleep in the UK and how they eat and their metabolic health. Unsurprisingly, found that people who report sleeping less tend to be heavier, and they tend to have some worse markers of cardiometabolic health too. I also was involved in a randomized controlled trial of melatonin supplementation as a prophylactic measure against the development of type 2 diabetes. And while there are many reasons to think that melatonin supplementation could help improve many aspects of health in chronic diseases such as diabetes, we didn't find that supplementation over a few months meaningfully affected an awful lot. And then I also did some work looking at validating a dietary recall tool known as MyFood24, which was designed specifically for use among UK adults. And I spent a lot of time in the lab measuring concentrations of various analytes in urine samples, which was great fun. So it was really a mix of different things, all converging on that theme of how does how we sleep affect what we eat, and in turn, our risk of diseases such as diabetes and obesity.
So in terms of the correlation you found between sleeping less and increased risk of metabolic disease, what do you see as the reason for that correlation?
Obviously, there are many metabolic diseases. So you've got non-alcoholic fatty liver disease, type 2 diabetes, obesity, and so on. But with that said, I think we can clearly identify certain reasons that poor sleep contributes to the development of metabolic diseases in general. I'll also add that using poor sleep as a term is not very clear, just in that sleep can be disrupted in many different ways. When we think about sleep health as a construct, there are several dimensions to it. There's how much time people sleep, so what's somebody's sleep duration per 24 hours. There's the placement of that sleep within the 24-hour cycle. I mentioned earlier chronotype, and that's in part what that would refer to. But you could also consider how somebody sleeps in relation to their chronotype. Take the example of a night shift worker. You could have a morning lark who has to work night shifts and therefore is working during the most strenuous part of their biological day. Then there is the quality of somebody's sleep. And with respect to sleep quality, there is how long it takes someone to fall asleep, their sleep latency, the amount of time that they're in bed, that they're actually asleep, which is sleep efficiency. So if somebody was in bed for 10 hours and they were asleep for 7 hours, then their sleep would be 70% efficient. There are other indices of sleep quality too. One would be subjective sleep quality, so how well do you feel you sleep? And that is important. And then there are some others, such as how you breathe during your sleep. There's an entire category of sleep disorders known as sleep-related breathing disorders, the most prominent of which is obstructive sleep apnea, which is very burdensome, especially with respect to certain cardiometabolic diseases such as diabetes. And then there's the variability of your sleep too. So if you look at your mid-sleep time from one day to the next, and let's say that one day it's 4 a.m., you go to bed at midnight and you wake up at 8 a.m. And the next day it's much earlier than that, then your sleep will be quite variable. And I mention all of those different dimensions because they're all independent predictors of risk of various chronic diseases and ultimately predictors of all-cause mortality, so risk of dying from any cause. Now, going back to the question about metabolic health, all those things are important. And if we just take insufficient sleep as an example, then we can tease apart some of the mechanisms. One would simply be that if you're awake for more time each day, then there's more time in which to sleep. David Dinges has done some nice work looking at the American Time Use Survey, showing that that is likely the case, at least among US adults. Another is that people tend to eat differently. And while a lot of people have speculated that this is due to hormonal differences, so there's some evidence showing that leptin, which is a satiety promoting hormone that basically correlates with your long-term energy balance. It tends to be a bit lower after insufficient sleep, and ghrelin, which is a hormone produced by the gut that promotes food intake, tends to be a bit higher. The data aren't entirely clear, and it could be that the relationship between those two things is the important thing, and the sleep loss skews that relationship in the direction of promoting food consumption. But with that said, the main way by which insufficient sleep seems to affect food choices might well be changes in patterns of activity in the brain. Specifically, people tend to respond more strongly to food, such that food is more rewarding and people favor instant gratification as a simplistic way of expressing those changes. So you're more likely to reach for the cookie than you are for the salmon and the broccoli. Other things that are likely at play are a change in how you then metabolize the nutrients that you consume. So specifically, insulin sensitivity is reliably reduced by insufficient sleep. And that, of course, is going to be compounded by people consuming more calories. If you look across studies, then people probably consume something like 250 calories more per day after insufficient sleep, which isn't compensated for by a corresponding increase in how many calories we burn, such that over time, that leads to a positive energy balance and people tend to gain weight. And then there are probably some other facts at play too. So one would be dysregulation of the nervous system. People might kick out more stress hormones such as cortisol, specifically at certain times of day in a healthy person who's well rested. Cortisol is a hormone that has a very high amplitude circadian rhythm. The circadian rhythm is just a rhythm that recurs roughly every 24 hours in the body and is self-generated. So it's not driven by behaviors such as eating. It's driven by your body's clockwork. And looking at the cortisol rhythm, you should see a sharp spike in cortisol synthesis shortly before you wake up each day. The purpose of which is presumably to mobilize energy reserves, to increase blood pressure, and to promote arousal so that you're ready for the waking day. And then as sleep approaches, and I'm sorry about the police in the background, you should see cortisol wane dramatically, and that supports the entry into sleep and helps consolidate sleep during the sleep period such that your sleep is high quality. But following sleep loss, it might be that cortisol early in the day spikes less dramatically, and then late in the day stays high. And in the context of insomnia specifically, what you tend to see is a surge in cortisol synthesis around the time that somebody's thinking about going to bed, because they start to find sleep stressful, and so they anticipate their bedtime and the fact that they're not going to be able to sleep, which perpetuates their insomnia. So that's probably another mechanism. And then some of the other changes in the regulation of the autonomic nervous system probably promote things like increased blood pressure. And then there's dysregulation of the circadian system too. So not getting enough sleep will change your patterns of exposure to artificial light, most likely. And that can itself be quite disruptive to cardiometabolic health. And while those just describe the mechanisms, I'll just add that if you look across large-scale cross-sectional studies or prospective studies, then you tend to find that poor sleep associates with substantially increased risk of going on to develop certain diseases in years to come. That's been shown for diseases including type 2 diabetes, obesity, and many others too. So that was probably a longer answer than you were looking for, but I tend to be long-winded, and that was actually quite brief for me.
There's definitely a lot to take apart there. I think one thing which you've touched on quite a few times, which would be interesting for the listeners, is the idea of chronotype. And you mentioned you're a very early bird. Ivan is also an extremely early bird. I'm not sure what you classify as an early bird, so that would be interesting to know as well. But how important is it to, so long as you're not a night shift worker, which may be a useful discussion as well, how important is it to sync to your chronotype, and how can you identify where you feel best, and how you can start moving towards that sleep pattern if possible?
Yeah, there's actually a lot in there to unpack. how can you identify your
Well, first off,
chronotype?
tell us what time you're waking up in the morning. We can see how early you are.
Well, I woke up earlier than I would have liked today. I was up about 4:30.
Okay, so yeah.
And that's without an alarm, of course.
And what time do you sleep?
Typically go to bed about 9:30, but then we'll occasionally have days that are much, much later than that.
And you still get up at 4?
Well, that's part of the difficulty for my particular sleep phenotype. It seems that
me too.
Even if I go to bed very late, I still wake up early. And some people have quite flexible chronotypes, and it's likely that those people can fare better in certain contexts. So, for example, if you look at the predictors of tolerance to shift work, then people that have greater flexibility in their sleep-wake timing seem to be able to adapt better to shift work and are more likely to stick with it. Whereas somebody with a more rigid chronotype, such as myself or Ivan, would be less likely to thrive in those circumstances. And I experienced that firsthand at university, working behind the bar. It was a pretty miserable experience in my first year. So,
but sleeping.
Yeah. So there's that dimension of chronotype, but if you're trying to compare your chronotype to different people to see where you fall on that spectrum of earliness to lateness, then there are, of course, systematic ways of trying to identify that. Those include some simple questionnaires. Possibly the best at giving you some quantitative output is known as the MCTQ, the Munich Chronotype Questionnaire Test. There used to be a website that people could go to and answer those questions and then be sent a PDF which would tell them where they sit on the bell curve for their age in terms of their chronotype. But that website, I believe, is now defunct. So you would have to score yourself using the appropriate methods to find that out. There are others such as the MEQ, the morningness, eveningness questionnaire. The problem with that is that it doesn't give the same type of quantitative data, and it also leads to, or is prone to, ceiling effects, in that the higher your score, the earlier a type you are, and the scale maxes out, if memory serves, at 81. So a lot of people will just hit that 81 number, when if the scale was 0 to 150, maybe they'd actually be at 102.
Yeah.
So there's that. Another important thing to mention is that chronotype describes where you sit relative to peers of the same age and same biological sex. If you think about chronotype across the lifespan, however, or if you think about sleep timing more specifically across the lifespan, then it changes. We all know this intuitively. When you're first born, your sleep-wake patterns are quite messy, as Ed probably knows firsthand at the moment. And then as your little one's sleep consolidates at the start of life, people will go to bed very early and wake up very early too. And then as they progress through maturation and reach the end of adolescence, they get later and later. Some people suggest using sleep-wake timing as a proxy for the end of adolescence for that reason. And then from adolescence, more or less until the grave, people get progressively earlier, such that by the time somebody is in their 80s, they might be even earlier than they were when they were, say, 6 years old. So there's that as well. And then another thing to mention is that there's a much greater dispersion in chronotypes in our modern 24/7 artificially lit environments than there would be in more natural settings. And this has been very nicely demonstrated by studies of what happens to people's sleep-wake timing when they go camping. Ken Wright from the University of Colorado in Boulder did a couple of really nice experiments, one in 2013, one in 2017, looking at what happens when young adults go camping in the Rockies for a few days. And one of the studies was done in the summer, one was done in the winter, And they found that over the course of those few days, the difference in sleep timing between the earliest person and the latest person reduced dramatically, such that by the end of a few days of camping, most of them were falling asleep not that long after sunset, and then waking up around sunrise, if not slightly later. And then by comparing what happened across the seasons, they found that sleep was longer during the longer nights of winter than it was during the shorter nights of summer, which makes sense. And the reason is that your body's clockwork tracks the photo period, tracks how long the sun is up each day, and can synchronize with that. But if you live in an artificially lit environment, then most people will assume some default sleep-wake schedule that's more or less invariant across the year. And what does this mean practically? It means that we should try and give ourselves strong time cues each day so that we can tightly synchronize our biological rhythms with the environmental clock, which is dictated by the rotation of the Earth around its axis, and hence the light-dark cycle. So with that said, just to go back to the other part of your question, what happens when people don't live in sync with their biological clocks? Lots of different things go wrong. And there are many ways of looking at this. You can experimentally disrupt somebody's circadian system. There are certain protocols that are used to look at this. One is known as forced desynchrony. In this type of protocol, you would take somebody and you would put them through a day, in inverted commas, that is outside the range of day lengths that your body's clock can synchronize to. And what that means is that your body's clock starts running free and loses time with the recurring day, in inverted commas. So if you impose a 28-hour light dark cycle as opposed to a 24-hour light dark cycle, your body's clock just won't be able to synchronize to that. It could probably synchronize to day lengths between something like 23.5 and 25 hours. So what happens is that after 3 of those 28-hour days, the person is basically eating and physically active at a time that's 12 hours misaligned with when their body's clock is well suited to eating and being physically active. And in those circumstances, you see things like dramatic reductions in insulin sensitivity, increases in blood pressure, reversed cortisol rhythms, increases in various inflammatory markers, which ultimately would be expected to contribute to disease. So you've got that type of experimental paradigm, which is very useful for dissecting mechanisms. But then there are different types of circadian rhythm disruption that we experience in the real world. One would be jet lag, which is probably the most obvious one that occurs to many people. And if you've ever been heavily jet lagged, then you know what circadian misalignment feels like. Another would be shift work. And with respect to shift work, trying to tie together different threads of what I'm saying now, if you can schedule your shifts such that you remove the most strenuous shifts for your chronotype, then you will likely feel much better, have a better quality of life, and ultimately reduce your risk of certain diseases. As an example of that, if you're a morning lark like Ivan or myself, then removing the night shift, which would be the most strenuous shift for us, would be a really smart thing to do. So there have been various studies in recent years by people such as Saline Vetter showing this quite effectively. Then there are some other forms of circadian misalignment. One is known as social jet lag. This is a term that was coined by Till Roneberg about nearly 20 years ago now. And the idea is quite simple. It's that if you look at the working week and the days in which people don't work each week, then for many of us, it's a bit like flying across different time zones. The weekend rolls around, people stay up later, they sleep in as well. And then come Monday morning, before the pandemic, probably something like 67% of Northern Europeans would shift their sleep at least an hour earlier. during the working week. And as a result of that, people might experience certain health problems. So that type of social jet lag has been associated with things like body weight and some different metabolic problems in men and women respectively. And then there are some other things that we could discuss too. So one would be artificial light at night. Exposure to artificial light at night seems to associate with risk of diseases such as obesity and quite possibly breast cancer too. One of the mechanisms underlying that might be that light at night suppresses melatonin synthesis in the brain. Melatonin is a hormone that helps tell cells throughout your body that it's dark outside, and hence to engage in activities that are appropriate for that time of day. But it also has quite strong antioxidant free radical scavenging capacities too. And it might therefore be important to things like the maintenance of the integrity of your DNA. And if that's compromised, then you could get mutations, and those mutations could ultimately lead to a disease such as cancer. And then there are other things too, like where you're positioned within a time zone. People who live in the west of a time zone are more likely to experience circadian rhythm related problems, because they will have to wake up earlier relative to the sun compared to people in the east of a time zone. And then if you take an extreme example, the whole of China follows Beijing time, but China spans 5 time zones, I think. So there are a lot of people in China who follow a social clock, which is completely out of time with their biological clocks and the environmental clock. And that's bound to cause problems, although it's not something that's been that well studied.
I had no idea about that.
Yeah.
Interesting.
Yeah, so sorry, another long answer.
That's really interesting, because I for this year, I finally gave up using my alarm clock. I was a slave to waking up at 5 a.m. and I used to always force myself to get up. Unlike Ed, I have the luxury of choosing when I want to wake up. But I finally gave it up in February, and for the last 4 months, just let my body sleep as much as it needs to. And after the initial sort of period, I settled into sleeping between 8 and 9 hours a night. And I tend to go to bed around 9:30, 10. I always wake up between like 6 and 6:30. And it seems to be really consistent now. Even if I try and sleep early, I just seem to wake up around that time. So that's been really interesting. And I'm assuming that's just me now living in sync with what my body needs and what's functioning well on.
Yeah, and that raises a related but slightly tangential topic, which is it's really important to only go to bed when you're actually sleepy. If you plan for whatever reason to go to bed at 9:30 and 9:30 rolls around and you're wide awake, you should absolutely not go to bed at that time, because especially if you have sleep problems, you will contribute to subsequent sleep problems. The reason being that if you then lie in bed awake, then your brain, being very good at creating associations between certain stimuli and certain behaviors, is going to learn to associate your bed, the stimulus, with being awake, the behavior. And for that reason, especially when helping people who have insomnia, it's really important to apply a principle known as stimulus control of behavior. And that's one component of it. Another would be if you wake up during the night and you don't fall back asleep within roughly 15 minutes, and you shouldn't be watching the clock at this time, you should go by your sense of time passing. Then you should get out of bed, go to a different room and do something relaxing and dim lighting until you feel sleepy again, and you should only then return to bed. And among people who have insomnia, waking up at a fixed time can be really helpful for a couple of reasons. One is that it will help build lots of pressure to sleep during the daytime. And that pressure to sleep will help you fall asleep quickly at night and then consolidate your sleep so that you won't wake frequently or for long periods during the sleep period. But another is that if you wake at a regular time, then those time cues that I didn't fully describe earlier will likely be more regular each day, which will thereby regularize the timing of your body's clock and make your sleep more consistent from one day to the next. And just to briefly describe what those time cues are, they're sometimes known as Zeitgebers. It's a German word meaning time giver. but they are stimuli that are involved in resetting the timing of your body's clock each day, which is important because were you to go and live in, say, a cave that's devoid of time cues, there's no change in light exposure over the day, there's no change in environmental temperature. Let's say that you just eat regular snacks every 2 hours round the clock, then what you'd find is that on monitoring the time of your body's clock wouldn't run at precisely 24 hours. On average, people's body's clocks run at roughly 24 hours and 12 minutes. So based on that, left to its own device, the clockwork would lose synchrony with the world around it. And to reset it each day, you need these time cues. The most important one being your patterns of exposure to light and dark. So spending at least half an hour outdoors in the day during bright daylight is really helpful for that reason. And trying to keep your nights dark and systematically reduce your exposure to light, perhaps beginning 1.5 to 2 hours before your planned bedtime, is a really good idea. The other time cues are likely physical activity, and this hasn't been nearly as rigorously demonstrated, but there has been some work in recent times showing that if somebody does, say, a bout of treadmill exercise, either in the morning or around lunchtime, then that will tend to anchor the timing of the body's clock early in the day, which would be helpful for a night owl. Whereas if they do it relatively late in the day, which for most people would be between about 7 p.m. and 10 p.m., then it will anchor the body's clock later in the day. So if Ivan or myself wanted to start sleeping at more human times, then going to the gym at 7 p.m. would probably help us shift a little bit later. And then the other one is the timing of your nutrition.
But just jump in there quickly, just for a bit of advice for clients then. If people are night owls and they want to shift to more of an early lark, would you recommend then shifting their training times to early morning to help that?
Possibly, yeah. And I recognize the practicalities of all of this because a lot of people can only get to the gym at one time of day. So discarding that, if somebody can control when they train, then if it's really important to you to shift your clock earlier, then I would say yes. But your body's clockwork influences probably every aspect of your biology and behavior. And one of those, of course, is your athletic performance. And if you look, say, at performance in strength and power activities, which I'm guessing is what many of your clients are most interested in, then performance in those activities quite closely tracks your body temperature, your core body temperature specifically, such that it's highest in the late biological afternoon. So most people will be strongest and most powerful at around 6 p.m. If you look at world records and Olympic records, then they tend to cluster in the late biological afternoon for that very reason. And there's a little bit of evidence, I would describe it as very weak evidence, showing that doing concurrent training or doing just weight training in the afternoon, when continued for several months, leads to very slightly greater increases in skeletal muscle mass and strength than doing it in the morning. But I'm not confident that that's truly the case. I think it probably is. I think it's probably quite a small effect. There's also some evidence that doing high intensity intermittent training in the afternoon results in better cardiometabolic outcomes than doing it in the morning. That was probably first well demonstrated by Julian Zierath, but there's been some more work recently by John Hawley's group finding somewhat similar results. Now, with that said, it's important to understand that your body's clock is plastic. So if you train in the morning regularly, then let's say that before that time, the best time to train for you was in the afternoon, looking at how strong you are and your metabolic responses to the training. If you keep training in the morning, then your body will learn to anticipate exercise at that time of day. So the clocks in your skeletal muscles and so on will get ready for that activity. And as a result of that, the difference in your strength and power over the course of your 24-hour day will be much smaller than it was before you started training in the morning. So while for many metrics, there's probably about an 8% difference in, say, maximal force production between the lowest point in your core body temperature cycle and the highest point, if you get used to training in the morning, that 8% number will surely come down. So it really depends what you're optimizing for. If you're just optimizing for acute performance, then the late biological afternoon is surely the way to go for resistance training. If it's really important to you to shift your chronotype earlier, then training early in the day is likely helpful, especially if you can do it outdoors during daylight. Those two things likely have an additive effect for those reasons that I mentioned. So both exercise and light exposure can shift your body's clock, and they do so in related but somewhat distinct ways. So that there are good reasons to think that combining them is probably a more potent shifting stimulus than doing either one by itself. And then finally, I'll just say an alternative would be, well, get outside early in the morning when the sun is up, and then keep your training in the afternoon, but just be really vigilant about you reducing your light exposure in the evening. That way you probably couldn't get the same size shift as you otherwise would be able to, but you would still be able to get a substantial shift, and maybe you could get the best of both worlds too.
Do you use any wearable tech in your day to day, and do you recommend any people to do so?
I do. I've got an old Fitbit which has served me very well. And why do I use that particular device? Because it gives okay step data and okay resting pulse rate data. Do I suggest that everybody use that type of device? Absolutely not. Can they be helpful? Yes. Can they be detrimental? Yes. Let me just expand on some of that. Sorry for all the long answers. So
it's fine. Just to give you some context, we dissected ourselves a couple of episodes ago, so it'd be really good to understand from a scientific perspective what's going on there.
Yeah,
especially just around how some of these can now track sleep, so the quality of that, how much you should be looking into that particularly.
Yeah, sure. So a lot of these devices will now provide data about the duration of sleep, timing of sleep, and many of them will also give people information about their sleep stages. So I'll just briefly describe those. As you enter sleep each night, you first go into what's known as non-REM sleep, and the other broad category of sleep is REM sleep, rapid eye movement sleep, which is that stage of sleep in which you have your most vivid and bizarre dreams, although you do dream in all stages of sleep. So first you go into non-REM sleep stage 1, which is the lighter stage of sleep. It's a bit like a bridge between wakefulness and sleep. You then go into stage 2 sleep, which is the stage of sleep in which you spend the most time each night. And this stage of sleep is characterized by a couple of particular phenomenon. One is known as a sleep spindle. It's a particular type of brainwave that's very important to the transfer of memories from a short-term depot in the hippocampus to longer-term storage vaults in parts of the neocortex. This stage of sleep also contains the highest amplitude brainwave. It's the most prominent on what's known as an EEG. These are called K complexes, and you can think of them as a detect and protect mechanism. While you're sleeping, your brain and your body remain aware of what's going around you. And let's say that your bed partner nudges you in the middle of the night, your brain will perceive that. But if it perceives it and thinks that it's not a concerning stimulus, then one of these K complexes will actually trigger your sleep to deepen in response to that. So it's detecting that, and it's protecting your sleep. And stage 2 is very important to things like learning as well, and to freeing space in the brain to learn new things. And then stage 3 of sleep, so-called deep sleep or slow wave sleep, is characterized by these very high amplitude brain waves. They're important to things like clearing metabolic debris from spaces within the brain. It's this stage of sleep in which many restorative processes take place. Your body produces probably something like 80% of its growth hormone during this stage of sleep. So it's important to repairing connective tissues. Growth hormone is also very important to neurogenesis in the brain. This stage of sleep is key to forming specific types of memory. So-called declarative memory of facts, knowing the capital city of a particular country, for instance. But it's also key to memory in the immune system. And this is very relevant to, say, vaccination. If you deprive somebody of sleep, and in particular of this stage of sleep around the time of vaccination, then their antibody responses to the vaccination will be dramatically lower than if they'd had enough sleep around that time. And then finally, there is rapid eye movement sleep. So from slow wave sleep, you'll typically ascend into stage 2 sleep and then go into rapid eye movement sleep. And it's a very bizarre state, sometimes known as paradoxical sleep, because your patterns of activity in the brain in many ways look like wakefulness. And meanwhile, your muscles, at least many of them, so not your heart or the muscles involved in breathing, become temporarily paralyzed, presumably so that you don't act out your dreams. And there are also other phenomena that take place. So if you're a guy, then you might get so-called morning wood during this time. You should do if you're healthy. And there are also dramatic fluctuations in things like heart rate, how quickly you breathe at this time. And this stage of sleep is very important to emotion regulation. And it's often disrupted in PTSD because of change in certain neurochemicals in the brain. But it's also key to trying to better understand the world and trying to form weak associations between your recent daytime experiences and your long-term memories to make sure that you're ready for the day ahead. And for that reason, it's probably key to things like creativity as well. Now, with that said, because of those different changes that take place in the body during these different stages of sleep, these devices can use sensors to try and make inferences about the stage that you're in. So, for example, if you're in bed and you're still, which can be measured using accelerometry, and your heart rate is fluctuating dramatically, which can be measured using pulse plethysmography, then the devices will probably score you as being in REM sleep, because that type of profile isn't really seen in the other stages of sleep. And what's happened is, over time, the devices moved from single sensor devices, so they just use accelerometry, to then having other sensors. And now many of them will look at things like pulse rate, core body temperature, skin conductance. And based on all of these different streams of data, they will try and score your sleep. They're not that good at doing that at the moment. The devices that do that quite effectively are head-worn devices that have electrodes that measure patterns of electrical activity in the brain underlying those electrodes, in a similar way to what you would do in a lab if you were using a so-called sleep study, polysomnography specifically, which is the gold standard way of looking at sleep stages. So there is a device, the Dream 2 headband, which is very expensive and probably is quite good at scoring sleep. And there are some other related consumer devices, but most people don't go for that, in part because of its expense, and it's not that common that people are familiar with that particular device either. I don't know if it's available in the UK. So you then have your wrist-worn devices and finger-worn devices, and the wrist-worn devices, I think, are probably particularly helpful because they tend to be better at looking at physical activity than some of the other devices. So if you look at the validity of wrist-worn devices, in assessing, say, step count tends to be higher than finger-worn devices. Whereas a finger-worn device like an Oura Ring has a couple of advantages. One is that people tend to keep them on. A lot of people take off their Fitbits and then not put them on thereafter. Whereas with an Oura Ring, because of its size and its form factor, they'll keep it on. Another is that it fits the finger quite snugly, and for that reason tends to give quite good heart rate estimates. It doesn't truly measure heart rate. To do that, you'd have to put something over the heart itself. It looks at pulse rate, but those two things tend to move hand in hand. They don't always. So if you're interested in your exercise in general and you want to look at your pulse rate because it will tell you something about how well recovered you are from your exercise, if your pulse rate is going down and your pulse rate variability is going up, then those tend to be good things. Then something like an Oura Ring is going to be good. Whereas if you want to monitor your step count because you're trying to lose fat and you don't want to see a reduction in your activity because that might lead you to burn less calories each day, then I think a wrist-worn device is probably better. Whereas if you wanted to look at sleep, then a head-worn device is probably more helpful. Now, with all of that said, I do think that how people interpret the data is really important. In the last few years, there's been a rise in people turning up at sleep centers, self-diagnosing sleep problems, saying, look, doc, I've been wearing my Garmin and apparently I got 2% deep sleep last night, 2% REM sleep, and then the rest of it was light non-REM sleep. And that's a problem because I understand that about a quarter of my sleep should be REM sleep and about a quarter of it should be slow wave sleep. And the reality is often that the device is just inaccurate. And if you further objectively assess the person's sleep, then their sleep is absolutely fine. So if you've got somebody who's already anxious about sleep and they wear one of these devices and then the device tells them they slept horribly the previous night, then that's going to exacerbate their problems. And there are some data showing that if you objectively assess somebody's sleep and they sleep well, and you then tell them that they sleep badly or that they slept badly, then as a result of you telling them that, their, say, cognitive performance will be slightly impaired. So with all of that said, if your sleep is quite typical, you don't have a sleep disorder, and you just feel quite tired and you're concerned that you're not getting enough sleep, putting on one of these devices and looking at the long-term trend in the data, recognizing that the data, if they are biased, they're probably systematically biased. So maybe they regularly slightly overestimate your sleep. Looking at the long-term trend can be helpful because it's going to tell you something about how your sleep is changing over time. I wouldn't look at the sleep staging data. I would just look at sleep duration. But if you have, say, a sleep disorder, let's say that you've got insomnia, then the devices are probably less accurate because they tend to be trained on data coming from healthy people. And if you look at somebody who has insomnia, then they might be lying in bed wide awake, but because they're still, maybe the Apple Watch scores them as being asleep, then the data will therefore be less accurate. Whereas if somebody has restless leg syndrome, they could be fast asleep, but kicking their legs furiously a couple of times a minute. And the device will therefore score them as being awake. So it's really context specific. And the final thing that I'll say is that it's really important to recognize that the devices are getting better over time. And if the manufacturers can create accompanying apps that are genuinely helpful in improving people's sleep behaviors and deliver the data in a way that helps them behave in a more optimal way, then they have huge potential. And there have been a couple of small scale studies. So one, for example, was published on the Whoop strap, showing that among people with relatively healthy sleep, wearing a Whoop strap for a couple of weeks probably slightly improved certain aspects of sleep by giving people appropriate sleep related advice. So again, sorry, long response, but it's a really nuanced subject. And I just want people to understand that they definitely have their place, but you need to understand a few different things and don't get too hung up in the data. Just look at the long-term trend. And if your sleep is quite unusual, then or if you're very anxious about your sleep, then I would consider passing it over to your bed partner rather than wearing it yourself.
As you said, a couple of questions that always come up with clients is around waking up to pee and having the need to start waking up to get up to pee, and it disrupting their sleep and becoming a frustration, especially when they start living slightly healthier habits. And the other one is around managing sleep during stressful times and finding that it takes a massive dive and being able to sort of navigate it. What are some of the sort of quick tips that you can give on each of those?
Okay, so quick tips for waking up to pee. There are many reasons that someone could wake up to pee, but just to simplify them, one would simply be that somebody is drinking too much. This is known as global polyuria. They're drinking too much throughout the day, and simply restricting their fluid intake at certain times will help reduce that. And as a rule of thumb, I typically recommend that people stop drinking fluids by dinner time, and that often works quite well. But another one might be that somebody has quite a small bladder capacity. So if somebody has a large prostate, for instance, then that could contribute. That's probably not the case for many of your clients, but there are things like questionnaires that people can look to help identify the sources of their problems. Another one would be dysregulation of your body's clock, and specifically of a hormone named arginine vasopressin. And that could contribute to increased water loss during the sleep period. And then a key one, but again, probably not one that's so relevant to your clients, is sleep apnea. Because during this condition, what happens is the upper airway intermittently collapses. And when that happens, you see a strong activation of the sympathetic, the fight, flight, freeze, or fornicate branch of the autonomic nervous system. And as a result of that, you see an increase in the production of certain stress hormones, which can themselves promote nocturia, so peeing during the night. And there are other things that can contribute to that. But if, say, your bed partner has seen you stop breathing during the sleep period, if you wake up with a very dry mouth, if you wake up with bad breath, then it could be that you have some sort of sleep apnea, low-grade sleep apnea. There's a questionnaire online available at stopbang.ca, stopbang.ca. And that's a validated questionnaire that helps identify people who might well have sleep apnea. So you can go and check that out if you think that might be the case. But I mentioned stress hormones there. I think change in some of those could explain this during, say, rapid fat loss. So obviously, as a, say, physique competition nears, people get very, very lean, and they often find it really hard sleeping through the night at this time. And I think that much of the time that's probably driven by changes in the nervous system. And presumably one of the reasons underlying that is that their bodies are in a state of a chronic negative energy balance. And by waking up, that gives them more opportunity to go out and try and find food. So when somebody refeeds over a sufficient period, those nighttime awakenings will probably be reduced. But a lot of people have rapid fat loss as their main goal, so it's just something they have to put up with. And then finally, the other obvious ones would be overdoing it with caffeine. And I say that because caffeine is not a particularly potent diuretic. It's not something that strongly stimulates urine production, and there are probably some sex differences, but it certainly can fragment sleep during the night, especially if it's consumed too late in the day. And I typically recommend that people stop consuming it by about 8 hours before bed, although there are huge differences between people in how they metabolize caffeine, depending on things like genetics and liver function. So caffeine is definitely one of them. And for many people, during fat loss phases, their caffeine intake goes up. And then the other one would be alcohol consumption. Again, probably less relevant to your clients, but alcohol has that effect through a few different mechanisms. One, of course, is that it does act as a diuretic. But Another is that it's a muscle relaxant. And for that reason, if somebody has obstructive sleep apnea, say, then they're going to be more prone to those apnea and hypopnea events because the muscles of the neck will be even more relaxed. So the airway is even more likely to collapse. And then because of the metabolism of alcohol, some of the byproducts of that metabolism might promote wakefulness during the night too, which could compound that issue. So that would be another one. And then moving on to the next question, there are lots of things that people can do to help reduce stress-related wakefulness during the sleep period. And if we look at this in the context of the COVID-19 pandemic, then there are probably a few things that I'd recommend. So for one, obviously, you want to try and reduce stress. It's a really facile thing to say, I know, but if there are avoidable stresses that you're currently exposed to, then trying to do away with those is bound to be a good thing. So this would fall under the category of coping strategies, and specifically problem-based coping strategies. Another would be using active coping strategies, and these include things like being physically active or exercising during the day. Doing mindfulness meditation can certainly help with sleep quality in many people. There's probably a small minority of people that might actually experience worse sleep after meditating, but on average tends to improve sleep. And it does that through a few different mechanisms. One is helping with self-regulation during stress, but another one is probably reducing pain, which can be very, very relevant to some clients. So building in a regular meditation practice, which could start with just doing 1 minute of meditation a day. And then as you start to make that routine, you can extend the period in which you meditate each day. You don't need to jump in with 10 minutes, 7 days a week. For a lot of people, that is enough to put them off. And then a really helpful strategy is engaging in scheduled worry time each day. And I've used this quite a lot with some of my clients. Typically, what I'll have them do is block off a period of 10 to 20 minutes around the end of dinner, because when you're trying to build a new habit, if you can, and I'm preaching to the choir here, you guys know a lot about this, I'm sure, but if you can tack your goal habit onto the end of an existing habit, then you're more likely to do it. If you're trying to get in the habit of meditating, then maybe you do that while waiting for your coffee to cool down in the morning, for example. So in this instance, doing this at the end of dinner will be helpful because most people eat dinner at roughly the same time each day. And the idea here is that for many of us, we're busy during the day, and that busyness can suppress any ruminations or concerns that we have. But then late in the day, as we start to take our foot off the accelerator, those different concerns will bubble up to the surface. And if they are in any way overwhelming, then that can interfere with sleep initiation and sleep maintenance. So the idea here is that during this 10 to 20 minute period, you sit down with a piece of paper and a pen or a pencil, and you list whatever you're concerned about. And then adjacent to that, you list the smallest next thing that you can do to address that concern. And if there's nothing that you can do about it, say that it's some sort of large scale global concern, then you just list that. But the idea is that you commit to not worrying about those things until your period of scheduled worry time the following day. And then another one would be just making a to-do list for the next day can be really helpful. So there's been some nice work by some research in the US showing that during transient insomnia, making a to-do list helps people fall asleep faster. So if you're someone who's very busy at work, you've got lots on your plate, and you go to bed thinking about everything you have to get done the next day, then probably around the time that you would finish doing that worry time, just making a to-do list can be really helpful, getting those thoughts out of your mind. And then there are some other things too that you can do, of course. And I think the most relevant of these right now probably include things like being very careful in curating your exposure to the news and social media. So if you read news that you find distressing, trying to confine that to early in your waking day maybe you do that around breakfast time and not shortly before bed. And then another one would be being careful about how you use your electronic devices. There have been many studies now looking at problematic smartphone use and sleep, showing that problematic smartphone use associates strongly with poor sleep. And there's been some nice work in the last couple of years showing that if you take young people who use their phones very close to bedtime, maybe within bed, and you have them turn off their phones at least half an hour before bedtime each night and then keep them off until the next day, then they fall asleep faster, they sleep longer, their subjective sleep quality improves, the next day their mood is better, and some aspects of their cognition improve, such as their working memory. So simply turning off your devices at least half an hour before bed, keeping them off until the next day, getting them out of your bedroom, keeping them out of your bedroom is a really simple but effective strategy for lots of people.
Awesome. I think there's a lot there for people to take away. We're going to finish up on a rapid fire, which basically one word to give you the answer for each of these questions, to see your thoughts on it. And then you can tell everyone where they can find out more about Greg Potter. So 3 questions. First one is the number one tip to sleep better tonight. What's one thing someone can do after listening to this podcast? You can crack it to one.
I'll give you two words. Stimulus control, which I mentioned earlier. So only go to bed when sleepy, get out of bed if you've been awake for at least 15 minutes, and save your bed for sex and sleep only.
I like it. Best thing to do with your lifestyle from tomorrow.
So I just rewind the clock, but this is all massively person dependent. So
yeah.
bear that in mind.
Take the caveats out.
Yeah. For your lifestyle tomorrow, use some sort of stress management practice. Doesn't have to be meditation, doesn't have to be exercise, something that you do each day to help you better cope with the stresses of modern life.
And the final one, what's the best thing you can do for your future health?
Listen to this podcast.
Yeah. Go to resilientnutrition.com. No. Try and mimic many aspects of the lifestyles of people who lived 10 to 20,000 years ago. So that means being a tight-knit community, spending time outdoors in nature, eating high-quality local food, being physically active in order to get your hands on food, dancing, having sex, and so on.
I like it. Where can people find out more about you?
They can find out more about me personally at Greg Potter PhD on Instagram. I'm also on Twitter. I don't use that an awful lot. Don't use Instagram that much either, but I do post occasionally. A lot of it is about sleep and circadian rhythm, so hopefully people find that helpful. But then I mentioned Resilient Nutrition at the start, and a lot of content I create goes out via resilientnutrition.com. I've recently written blogs about things such as how to cope with poor sleep, how caffeine affects us. There's a free ebook named The Principles of Resilient Nutrition, which outlines much of how I think about nutrition specifically. And we're also on social media at Resilient Nuts. Again, a lot of that activity is on Instagram.
Awesome. Well, thanks so much for all your expertise today. I think there's a lot for people to dissect, make notes, and then ultimately take action into their days. So really appreciate your time. And I'm sure our audience are going to find a lot of value from it.
Pleasure. Thanks, guys.